Okay, good morning, everybody. Hi, how you all doing? Nice to see you this morning. I hope everybody's well, and wherever you are in the world, that your lockdown restrictions aren't affecting you diving too much. Be nice to see everybody this morning. Andy, how you doing? Kath, good morning. Dave's here as well. Hi, Dave. How you doing? Just move up this little window for a second. Mr. PT, how you doing, Damo? A few people joining. Glenn's joining in. Mark Crane over from Bali. Nice to see everybody. Ludo, hi Ludo from Mauritius. Just having a bacon butty and a brew. I can do with a bacon butty at the moment. Getting on a bit on the fat side though with this lockdown, so less bacon butties for me. Wait for everybody to come and join the room for us in a minute. Today we're going to talk about the P2, obviously. Quite an interesting rebreather actually. So this is a brand spanking new machine you're going to get to look at today with a new specification. So it's going to be a really interesting discussion. We're going to compare it to all the other rebreathers we've seen. Good morning, Greg. Good morning, John. And the idea will be to show you some differences, show you the unique features of the P2, and compare it to the other rebreathers like the JJ, the SF2, the Revo, the Poseidon, and the AP that we've already seen. And next week's presentation will be on our Maris Horizon that you can see sitting back there. So we'll then have a pretty good list of most of the rebreathers available on the market. So it should be good fun. Hopefully I managed to get the screen the right way around today, so you guys should be able to see everything in the right orientation. Just let me know if that says Prism 2 in the right orientation for you. Paul Wells, hi, how you doing? Justin's here, Ollie's here. Hi guys. James, how you doing, buddy? We saw you outside the shop the other day, but you didn't come in. I wonder why that was. You're welcome to come in any time. Michael Corden, I haven't seen you for a bit, dude. How are you? Good. Fantastic. Right, so we're going to give it another 1 minute. Just let a few more people join the room. There's 28 of us now. Waiting for a couple more people to join, and then we're good to go. Hollis Rebreathers UK. Good morning, Trevor. How are you doing? Thank you for all your help with this session. Paul, we're good, mate. Yeah, everything's fine at the shop. We get to start diving again. Stony opens from the 17th. We've got Vobster opening around a similar time, and Chepstow opening from about the end of the month. So it means we get to go diving again pretty soon, which we're all happy about, of course. Right, fantastic. So let's get started. Today's video is about the P2, obviously. The P2 is a rebreather made by Hollis, so one of the large manufacturers, Hollis Oceanic, owned by Liquid Sport, distributed by Liquid Sports here in the UK. Quite a big company, of course. They've got a lot of brands underneath them from the Hewish family, so Atomic, and they've got Salsac and Oceanic, Hollis, of course. So big manufacturer building a rebreather that's going to push through their dealer network. So it's quite a proven product. So 8 years this machine's been on the market. It's recently passed CE though, so it means that we're a bit easier to teach this now inside the European market. Nice thing about this rebreather in particular, it's got the lowest work of breathing of any of the rebreathers we've tested so far. So 1.75 joules, that's using air at 40 meters. So super low work of breathing. What does that mean? Obviously the breathing effort is what you're the pump and you push the gas around the rebreather. The easier it is for you to breathe, the less effort required, okay, because the actual mechanical work of breathing. So having a really low work of breathing is important. Number one, reduce the amount of CO2 your body's going to generate, and it increases the ability for your body to push that air around the rebreather. So interesting fact about this rebreather. Another thing you'll notice is that it's made with very few failure points. So for instance, all the hoses go from where they start at the first stage to their final destination. There's no T-pieces, splitters, or any hose-to-hose connections. So made with very few failure points. Everything goes direct. The other interesting thing is that this machine is really light, kind of Poseidon light. 25 kilos, fully ready to dive. So cylinders and softener lime inside the machine, full built up, 25 kilos. When you want to travel with it, it's 14 kilos. Take the stand off, you're down to 13 kilos. So super lightweight, kind of get this in your hand luggage for most airlines. And of course, you can see from the compact design, if I remove the top, you can see it's even smaller. So that's just a case. and you can see that the machine then it breaks down from these component parts as well. So really easy to pack and travel with. Some other unique features about it, it's got custom first stages, so I'll show you in a minute. All the first stage designs are designed for the best, most optimum hose routing for a rebreather. Fits any size cylinders, a lot of the rebreathers on the outside. You can put 7s, you can put 3s, you can put 5s. I wouldn't put 12s on, but no reason you can't. Nice feature on the oxygen side of this rebreather, it's got a low flow for the solenoid and for the oxygen MAV. So they're built into the hoses. That means if the solenoid was to stick open, the flow of gas would be low. It's not the full flow of a hose and the IP. So it's a reduced flow, both to the MAV, so you can't inject too much, and into the solenoid. So if the solenoid was to stick open, it'd be a low amount of gas flowing. CE certified to 100 meters now, using Trimix. Interesting one about this is the first rebreather that we've got in our series that's got a radial scrubber as standard and in the CE. So the radial scrubber is part of the design of this rebreather. So we'll go through that in a minute. Now, the Hollis P2 is sold through the Hollis dealer network, and that means that you're going to get the dealer support rather than being sold through individual instructors, a lot like some of the other rebreathers. It means that warranty and parts are all going to be held at your local dealer, so you shouldn't have to worry too much about shipping those from abroad. The actual Rebreathers UK, which is the company that are distributing these, based down south, they've got all parts and all major service in stock. So the interesting thing is that if you need to have, let's say, the electronics split open and something changed, they can do that here in the UK and then repressure test them and repressure test the head back to 50 meters to make sure that it's working. So that can all happen in the UK, but you're not going to have to ship backwards and forwards. Will's just posted a link there for you guys in the comments. If you are watching this video today, Rebreathers UK have kindly offered a £500 discount from a P2, provided you buy it before the 31st of July. So you've got best part of a month or a month and a bit to go get 500 quid off the price of a Hollis P2 if you're interested, just by watching this video and by being part of this this Facebook Live. So to do that, you're going to need to go online on the Rebreathers UK website, just register yourself for a voucher, and then you can redeem it through any one of your Hollis dealers, so the closest dealer to you. Talk about other features of the rebreather. It's got a scrubber design that lasts 190 minutes under CE conditions. If you go down to 1.6 litres of CO2 at 100 metres, you get 215 minutes out of this scrubber. So quite a long time on the scrubber. We'll talk a little bit more about that in a minute. It's got the shear water electronics that we're used to seeing from the SF2 or from the JJ. So it's got the shear water handset, and this one also has the shear water HUD. Can come with a NERD. It can also come with a third controller as well, or at least monitoring device. So if you notice here, we have one port, and this port is for our handset. We have this port over here, and this port is for our HUD. We can also have another port here, so we can have a third handset or a third HUD built into the rebreather really quite simply. So quite a modular design, and you can add to it. And as we go through, I'll show you the small interesting parts of each of it. When we talk about the scrubber, you'll notice that the scrubber is built in this clear bucket, and so you can actually see the scrubber. Being able to see the scrubber means that you can see, number one, that there's lime in it. That's a helpful start. But secondly, if the machine's flooding from the back, you'll notice that the fluid will move up through the scrubber, and you can see it flooding. So quite a nice feature of the rebreather. If you compare it in weight to the other rebreathers, the weight is about the same as the Poseidon. In terms of the JJ, it's a significant difference in weight, and certainly in its modularity. You can split this down and put it into different bags and kind of split the weight across, and you're only talking 14 kilos to travel with. So that's probably its main market, I think. So let's go ahead and let's start. Of course, we're going to need our checklist. So this is the Hollis back-mounted assembly checklist, because this machine can come with front or back-mounted counterlungs. The ones I'm going to show you today are going to be the back-mounted counterlungs. Then we've got the wing and back plate that also go on. So we get a Hollis wing. When you specify your rebreather online, you can actually choose which wing you want. But this is the donut wing. It's a 45 pound wing. So 45 pound a lift donut wing. Pretty similar to what you see on a lot of the rebreathers. Same thing with the harness. So this one's come with a steel back plate. Of course, if you don't need the lead, you can go for a lighter back plate. But steel back plate with a one-piece harness already built in. You can change that during your configuration as well. If you guys want to ask questions, by the way, Please feel free to ask questions in the comments. We've got Will on the other side of the computer also typing comments out, so if he can help you, Will, and I'll try and answer what I can online as well. So if you've got questions, please ask as we go along. I might just wait a minute till we get to a point where we can stop. So what we've got our H plate. And the H plate is this aluminium plate you see right here. It can be purchased in steel as well, but this is an aluminium version in black. Everything connects to this H plate, but they are just finger tight screws. So I could undo those and remove the head. I could, if I wanted to, remove these ones and remove the stand as well. You'll notice that the stand, even though it's steel and even though it's quite sturdy, is made out of quite a thin stock of material. That means that the weight isn't affected too much by the stand. It's kind of just about a kilo. When we take a look at the top, you'll notice on the top of the head, I'll turn it a little bit towards you, you can see we've got the battery compartment here, and inside there are our batteries. We'll open that up for you so you can see. Take the two clips and remove those. They lift off. Then we've got the world's most heavy battery compartment. To say it's a lightweight rebreather, this is a really kind of probably 500-600 gram piece of machined billet steel with an O-ring here and an O-ring on the top. So we need to make sure that both those O-rings are clean. You'll also notice that there's an overpressure valve built in there. So should the pressure build up too much inside the battery compartment, then it will vent rather than damaging your electronics. When we look in the top, you'll see we have the same battery layout as the JJ. We have two 9-volt batteries, and they control the main board and the solenoid. And then we have one single lithium AA battery that controls our HUD. An interesting feature of this rebreather is, if I can get it out, is the batteries come with a removable clip. So what you can do is, should you damage the wire or one of the connectors, you can just remove the clip, and then the pins in there, it just pushes into. It's also important to know that the pins on the other side go into the board are also on a clip. So even if you damage a pin, in the UK they can just undo the head, change the cable, and then reseal the head and retest it, and that means you've got that side fixed as well. Some of the other rebreathers, the cables are hard soldered to the board. If your board was then potted in compound, you would have to break all the potting compound and replace the shear water board as well, which is significantly expensive. So one really nice feature is that the cable to the batteries is removable and replaceable. Okay, you can do that yourself as a user. So I'm just going to pop that in there. There we go. I have to say, not a fan of the pink foam. I think the pink foam makes it look a little bit kind of DIY. But at the end of the day, it protects the batteries and it does its job. So there's my battery compartment back in. I'll confirm these two O-rings are good, which it is. Confirm the O-ring on the top is good. Bit of grease on it. And it doesn't matter which way round you go. So we pop that into place like so. Line it up with our clips, give it a little press. Then we flick on our clips. Okay, have a look around, make sure the seal's good. So that's our battery compartment. Coming down from our battery compartment, of course, we have our electronics module. We have our two connectors, which we'll come to a little bit later on. These are the standard shear water dive cam connectors. And then we have inside the head. I want to show you guys inside the head because it's quite important. Hopefully you can see. So inside the head here, we have some really important things. We have this here. This is our CO2 seal. This is a life critical part. Without this in place, the exhaled gas that comes down the centre would pass over and back to the inhale side. So if you can see the inhale side there, okay, there we go. There's the inhale side, the hole, and the exhale side is this inside this red circle. So you exhale through here, it goes down the centre of the scrubber, passes out radially, and then comes back up the outside and through that hole back to the diver. If this, which is a rubber silicone type connector, if this seal is not in place, your scrubber will not seal against the head and gas could pass from side to side. That's why it's bright red. Critical that it's in place. It's on the checklist 3 times actually to make sure that it stays in place. And of course, it's removable so that should it become damaged or should it become even slightly marked, it can be put in place. But the nice thing about it is because it's silicone, it's not like an O-ring. Once that's in there, it doesn't fall out. Even if I give the machine a damn good shake, that thing won't come out. It is really tight in there, so it's quite a nice feature. Next one, the cells. 1, 2, 3 oxygen cells. And these cells are an interesting design, something I've never seen before. If we pull them out, you'll notice that they're fitted into a squishy rubber bumper. And that rubber bumper's got two little holes that fit over these two mounting pins there. And that stops the cell getting damaged during transportation and knocking around. We all know how critical keeping the cells in good condition are. So that with these being fitted into like a shock absorbing bumper, it means that they are as well protected as they can possibly be. Now, a little bit fiddly to get them back in. You just need a little bit of grease and a little bit of patience, which I'm not famous for, I know. And you push one side down like that, and push the other side down like that, and then they go back into place. Again, worth noting, if you look here, the electronics themselves, same thing, have a removable plug. So I can remove the plug to all three cells. That's nice because if a cell plug was to become corroded because of the moisture inside here, I can very easily just change the plug and then clip it back into place. Exactly the same thing though. On the other side of the plug is also a cable which is double plugged each end inside the electronics. So should I damage the pin connector or the pin connector become corroded, I can change the cable inside the electronic head. That will require service center because it needs repressure testing, but it's all possible as well. So, interesting design. Let's talk a little bit about the connections to the head then. Top of the head, we have our solenoid feed, okay? Our solenoid feed goes in and through there, okay? And the O2 injection is done on exhale. So a little bit like the SF2, the O2 injection is done on exhale. So it injects O2 into here and then down into the scrubber bucket, okay? Two hose connections on the top right there. Now, with it having O2 injection on the exhale side, okay, that means that the calibration procedure needs to be a manual calibration procedure, whereas the JJ has the automatic calibration procedure. The SF2 and the Hollis can't have that procedure because what they would do is in the automatic calibration procedure is open the solenoid. That solenoid would need to fire gas towards the cells or in this cell mixing chamber to be able to make that calibration. With this rebreather, what would happen is the gas would go down, it would flood the scrubber bucket eventually, flood the hoses eventually, and then the cells, of course, would come up to oxygen, but that'd be quite wasteful of gas. So it's done in a slightly different way. The SF2, for instance, has a calibration kit that we fit, whereas the P2, some people are making a calibration kit, but if you follow the checklist exactly, you'll see that the calibration is done in a slightly different way. So, let me just take a quick turn around and kind of show you all sides of the rebreather. Fantastic. Oh, just let me point out, this is another little cool feature that I quite like. When you take off the retaining bolts for your backplate wing and counterlungs, take off you can see that there's actually a lock-in ring in there that stops that bolt falling out, so that's quite nice. Again, you know, it's like when you're lying down on your boat, you're trying to get your counterlungs or something off. It means that you're not going to lose your bolt down the side of the scuppers on the boat. Right, so our first step in our checklist is to fill the scrubber basket with CO2 absorbent and store in an airtight container, okay? So the date I've packed it, it tells me my durations as well. I get 190 minutes at 40 meters with 1.2 CO2. The amount of CO2 I'm producing is 1.6 litres. 215 minutes if I'm producing 1.6 litres of CO2 at 100 meters. If I'm only producing 1.6 litres of CO2 at 18 meters, and then again I get 190 minutes. So you can think of this scrubber as 190 minute using air or 215 minutes using trimix. Okay, so slightly different to the other rebreathers which give you a single figure. Okay, this figure has two figures, one based on trimix and one based on air, and that's due to the density of the gas. Okay, so this is our scrubber design. You can see here that it's a radial scrubber, so it's different to what we've seen before. Where in axial scrubber, the gas would move from the bottom up through the flow into the top. In this rebreather, the gas goes down this central tube and then radiates out in all directions, comes back up the outside and then into the rebreather. So completely different design to the axial. It's actually, this is the top and this is the end that fits, and you can see it says here, just an extra check, this end up inspect that red CO2 seal because it's so important. It fills from the bottom. So what you're going to do, put a little bit of friction on there and the bottom plate will unscrew. This leaves you with the hole where the gas is going to come down, and of course the area where the softener line is going to be fitted. There are some foam pads, and those foam pads are designed to keep the material compressed. They're also there to make sure that the gas doesn't find the easiest path. Now, one of the nice things is it is set back here. So what can happen sometimes on a video scrubber is the gas can pass through the easiest point. And if you imagine that was like that, and started to shake, and all the material settled to here, the gas that was coming down the inside would find the path of least resistance, and that would be directly out the top and back to the diver. So by having that little gap, even if the material settles slightly, the quickest way through still isn't over the top of the scrubber. The answer is yes, yeah, you can order the CE upgrade kit. The CE upgrade kit, though, means your machine is going to have to go back to our Rebreathers UK, because these two ports here on the non-CE were the same thread. For CE, they had to make one the opposite hand. So to change this is not a problem, it's just a plastic part. We're not talking a lot of money, but the problem is you need to have your electronics module moved from one to the other. That's fine, again, not a lot of money, but what it does mean is it does mean that it needs re-pressure testing. So you just can't do that at any dealer. It needs to be re-pressure tested to 50 meters. So back to our scrubber. You'll fill this with lime. Again, we won't show you, but it's more of a difficult procedure than the other rebreathers because you've got to be able to get this well packed. Any small variation, you can see that the gas has to pass from here to here is a lot shorter than the space of the gas passing all the way through. So you need to make sure that the packing is really well done. Interesting feature is that when you try and fill this with softener lime, of course, you have to be careful that you don't fill that hole. Otherwise, the minute you lift it off the table, you're left with a small pile of softener lime on the table. There's a few interesting methods people use. Some people put the softener lime cap on the top. Some people put a golf ball in there, but you're going to need something to cover this hole. You can, of course, just use your hand and pour it over the top of your hand. But it does make packing a little bit more difficult with this scrubber than any other, but you get the benefit of the added life. So what we give with one hand, we take away with the other, I guess. Once you're happy, put the top on. That's it. We've got our assembled canister. Assume there's lime in there, please. So we tick that off on our box. One, it's full. Then we need to fill our O2 and diluent cylinders and analyse the content. So of course, we've got two cylinders. One of oxygen and one of diluent. I need to analyse those, of course. So always a good idea if you can analyse your oxygen first. That way you know your analyzer's working. So start the flow. I'm going to teach you guys how to analyse a cylinder. Hopefully you all know. Let the analyzer settle. Okay, 99.8, which we can then write on our cylinder. 99.8, 6 meter maximum operating depth. We can then write that here on our form. Then we can analyse our diluent. Who we got in the room? Got some people from Thailand, Shanine from South Africa, Amar, nice to see you, dude. Okay, cool, that's 20.9, so that's air diluent. I'm going to write that on our cylinder. 20.9, 66 meter maximum operating depth. And then we're going to put that directly again straight onto our sheet. Of course, it makes sense to pressure check your cylinders before you fit them to the rebreather. Spend all the time fitting them and then you realise there's no gas in them. So we'll use our pressure gauge and we'll just confirm there's gas in them. So 90 bar in our oxygen side, which is enough for what we need. Again, where possible, once you've done something, try to write it down so you haven't got to remember this stuff. Now the diluent. We have 200 bars of diluent. Put that down. And then, okay, good. They're now analysed and pressure checked. I can put those to one side. Samples are ready to go. The next step is to fit, take it off, install regulators and hoses to the H plate. So this again is our H plate, is what we're talking about. And we're going to take a look now at the regulators. So we've got one set of regulators for our diluent side and one set of regulators for our oxygen side. I'll come a little bit to the side so you can see. These are based on the old SP5 first stage, so it's quite a simple first stage. Remember, we don't need expensive high flow first stages on a rebreather. All they do is make sure that the gas is flowing at a really low rate. A couple of litres a minute is more than enough. So you can see the design. The design is so that all three ports come facing the right direction. There's two ports on the bottom. This one has an overpressurization valve in it and a spare for anything you might need later. Very simple design. On the oxygen side, we have, of course, a standard regulator fitting. Again, nice thing about these is they all use standard fittings, so you can change them at some point. So that then fits on the top. We have our pressure gauge. Of course, it needs to be in a green housing for CE. I would normally throw that in the bin myself. And these, you'll notice, are actually the big SPGs. Okay, so during the process, I was speaking to Hollis about why they fit such heavyweight SPGs to a lightweight, one not designed to be lightweight, but let's say a rebreather that one of its nice characteristics is the fact it's lightweight. Why don't they fit the standard, gauges that all the other manufacturers fit? And the answer is that their tolerance to damage and accuracy after that damage. So the smaller ones, if you bang them a little bit too much, then they start to go out of calibration because of the smaller parts inside. Whereas the big heavier weight SPGs are more accurate, especially when they've been kind of knocked and stuff. So to keep them in the best condition, they decided, even though it's more expensive, to fit the bigger SPGs, the type you would normally use for a back gas regulator, rather than a small deco gas one. So that's interesting. Okay, Greg, what's your question? Relative to the question for unit strength, like the lightweight, but any challenges on robustness? Rather pay for freight than have the unit work. No, you're right, mate. I think that's absolutely true. But what they've done is they've removed weight in the right places. So this scrubber bucket, you can see, is acrylic. But if you look at the thickness of it, it's a serious bit of equipment there. You're talking like 8 mil of solid acrylic. And we all know, acrylic is mega, mega tough. So super tough there. The steel stand, again, it's still steel. It will bend, of course, much easier than the JJ one will bend. But what do you mean in terms of robustness? That'll easily take a flight, won't it? Same thing with the aluminium backplate. Of course, the head is made out of form of plastic. So that bit, like most rebreathers, is the most expensive bit and the bit you want to protect the most. Other than that, when you see the counterlungs and stuff coming a little bit later, they're as durable and made out of the same cordura and stuff. So the fact that this is in fewer parts probably means that the entire durability is about the same as the other rebreather, and that's where it gains its lightness from. The only thing in terms of lightness I would kind of look at a little bit skeptically is the scrubber. So you notice that it's kind of soft mesh, and this is quite a light plastic. I don't know if you can hear it. So that would obviously need protecting. I would be a bit loath to put that in its bag on its own and expect it to get there in one piece. However, if you pack it inside there, then for sure it's going to be stable. So yeah, I think actually the lightweight has been done in the right way so that we're not going to have to worry too much about its durability. SPG could be a backup hammer. Yeah, absolutely. You can always go seal clubbing or something with this as well if you want, Peter. Okay, let's back to the O2 regulator. O2 side. Okay. So like we said, we have a standard regulator fitting, and that fits directly into our solenoid feed. And like I said earlier, very low failure point, so it's one length of hose. Of course, you've got to have a hose, so you're going to have the crimps and the O-rings on either end, but it's just a single piece of hose. SPG, same thing, single piece of hose. For my personal opinion, a little bit long, but again, not expensive or hard to change a hose. And then we have our normal standard LPI BC fitting, and that is for our MAV, our manual addition valve. So on the O2 side, 3 hoses attached to our first stage. Quite simple. On the diluent side, take a look at the diluent side. So the diluent regulator is the same regulator, but with a different body again. So because Hollis obviously manufacture these first stages, they can manufacture them how they like. And you'll see there that we actually have a 5-port configuration on the top. And on the bottom, the same thing. We have our overpressure valve and we have our spare. So we've got 5 hoses running up. At the moment, actually, sorry, we've only got 4, but you can have potentially 5. And where do these go? First, we have a regulator fitting, and this regulator fitting here screws onto the ADV, the automatic diluent valve that's based on top of the left shoulder. We have a single fitting here, which is the long one, and this is another BC fitting or LPI type fitting, and this is for our MAV, so manual diluent addition button. There's one more of those. Again, another low pressure inflator fitting, and that one is for our wing. And then of course finally we have the SPG, same as before. Okay, so you can see on our oxygen side, same thing, no hose to hose connections directly from the first stage to where it's going, reduce the amount of failure points. So we've got our set there. These need to be fitted to the unit. So what we're going to do, I'm going to out of the way a little bit, is I need to fit them, of course, oxygen side on the right side as warm, that's this side of the rebreather, and diluent on the left side as warm, which is this side of the rebreather. They fit up through these loops that hold the cylinders in. This bit takes a bit of a moment, so if you just watch me, if I was travelling I wouldn't actually strip this myself. Just wanted to show you guys how we do it. First thing I always put up is the SPG because it's the biggest. That will go up through there. Again, it comes up over the top of the H plate, and that'll end up down by your shoulder. Same thing now with our feed for our ADV. We can push that one up. BC fitting, just let me bring that around. ADV fitting goes up. That's going to end up to our shoulder. Same thing with our MAV fitting. That's going to end up to our shoulder. Put that through there as well. Just keeps all the hoses nice and neat and out of the way of the scrubber bucket later. We'll pop all those in place. The final one is our wing. And our wing can also go up and all the way to the top. I don't know if you guys can see, we fit those into place like so. So now we just make sure we pull everything nice and gently, making sure that it all moves up at the same speed. And our first stage is aligned in the correct orientation for what we want. Okay, so left side is worn is our diluent, right side is worn is our oxygen. I can then give this up a little pull and just collect all those hoses up. So same thing, the oxygen side. This time we have 3 hoses to worry about. Just lay it out, go with the SPG first. SPG up, all the way up, over the top. Solenoid feed up, and directly up, because that's going to go to our solenoid. And then the last one is our MAV or manual addition, and that goes up and in front. So once I'm happy that that's kind of in roughly the right place where I'm going to have my cylinder, I can then give that a little pull tight as well. Okay, so if I spin the rebreather around to the front, what you'll see is I've taken some up over the top. So coming up over the top, we have the SPG on the oxygen side, and on the diluent side, we have the SPG and our feed for our wing. Coming up through the centre here, and these will go through holes in the wing, are our manual addition buttons and our Counterlung ADV feed. So they're going to come through the centre like that. When I'm happy everything's in place, I can tick that the O2 system has been fitted on the right and the diluent system has been fitted on the left, and attach the solenoid supply hose. So this is our solenoid supply hose. It goes to our solenoid fitting right on top of the rebreather there. I want to make sure, of course, the O-ring is in good condition. This one's going to need a little bit of oxygen grease on it, and it's clean. Check again inside there. There's a filter built in there with an O-ring, so you just lift the O-ring out and then you can change the filter. Just turn it over and then put it in. You guys will notice that this actual bend in the hose is quite severe, and it kind of gets in the way a little bit. I would personally have preferred that to have like a 90-degree elbow on it to make ease of fitting and ease of hose routing neater. But, of course, looking for the reducing failure points, putting that 90-degree elbow in there would have caused a slightly different issue with the philosophy of the machine. So it just goes straight up and over. So you can see that fits into place. When you come to fit the loop hose a little bit later, it just makes it a little bit more fiddly, but what you're gaining from the other hand. So this might be a silly question, but where does the hose for a dry suit come from? So Pete, there's a couple of options for dry suit hoses. A lot of people will run it from their bailout gas. So they'll have the bailout gas with a low pressure inflator fitting that they then plug into their dry suit. That means that you're not using the onboard supply gas. The idea of these small cylinders on board is to keep the weight low and you're not using a lot of gas. If you keep putting a lot of gas from the onboard into your dry suit, of course you're wasting that gas and then limiting the space, limiting the range of your rebreather. So you could plug it into your bailout. You don't want to plug it into a trimix bailout, okay, because that's not ideal. You don't want cold helium entering your suit for lots of different reasons. And of course, if you want to remove your bailout, do something later, you're going to have to remove it and potentially not have dry suit. So what most of us do, don't take a look at the state of the cylinder, unfortunately, Pete, but what we use is a dry suit inflation system. So a separate bottle this is a small 1 litre bottle with a hose, and that'll fit onto our back plate just at our side here, and then supply the dry suit directly. So that our dry suit system is completely separate to the rebreather. Gives us a lot more options. If this was to fail, I can plug in from my bailout, and if I've got some gas in there, I can plug into the rebreather, I can do that as well. So dry suit inflation bottle is the best option. Okay, so there's our feeds. Attach solenoid supply hose, we've done that. The next thing is to install the BCD, back-mounted counterlungs and backplate. So I'm going to install the back-mounted counterlung. I'm not going to install the backplate or the BC, just so you guys get a better picture of what's going on. You will notice it looks a little bit floppy because there's no backplate to hold everything nice and sturdy, but just bear with me for that because it's designed to make it a little bit easier to see. So I need to remove my wing nuts. And remove the washer. So wing nuts and washer again, put those somewhere safe. Everybody loses the washer after the first couple of dives, so keep them nice and safe. And I'll show you the counterlung set. So I'll move this to one side. So this is our back-mounted counterlung set. You have a front-mounted counterlung set and a back-mounted counterlung set. So this is the face of the side that is facing the diver. This side is the back side of the counterlung set. And I'll show you each individual component. So if they're sitting in this direction, we have the exhale side. What you'll notice is that we have a really heavy, probably 200 gram fit in here. And this is a hose weight. We don't have a hose weight along the hose. The hose weight comes right at the end here. So that's the hose weight. It's also the fitting where we fit the DSV later. We have a single hose that's then got a permanent connection at the T-piece. This T-piece is a water trap and directs water into the exhale counterlung. It'll then come up and it's fitted then to a threaded section. An interesting feature of this rebreather you can see is that the O-ring is very easily accessible. It's not covered by anything. So you can see and inspect the O-ring really, really easily, but it is a single O-ring seal. On the other side, we have exactly the same thing. This is our inhale front hose, again with the weight in it. You guys that noticed rebreathers before will notice something slightly different here. This rebreather has a mushroom valve or flapper valve built into the hose. Okay, so on the incoming side, you have a mushroom valve built into the hose. Okay, that's our inhale side. It goes back, or at least it comes this way actually in reality, and we've got our ADV fitted on the top there. Our automatic diluent valve has a connector here that connects the gas supply from our diluent, and then it goes back to the head. And you'll notice now on the CE rebreather we have two different colours. We have clear and we have black, and these are opposite threads as well. In the previous version you were able to put these the other way around, but look how stupid that looks. Who dives a rebreather like that? So it wasn't a big problem, but to cover CE you have to interlock it so the loop direction can't be altered. In which case we need to put different threads on these. So this is the difference between the CE. Attached to each T-piece. On my inhale side, so coming to the diver, I have my manual addition button for my diluent. So the manual addition button for the diluent, the button sticks out, okay, so you can see it's proud, and I can press the diluent button, gas will flow in from this port that says in, out, and into the counterlung. On the oxygen side, I have the same thing, just attach the T-piece, and this button is actually flush. So if you look at the differences between the two buttons, hopefully you guys can see, you'll notice that the diluent button is proud, and so it's easy to press, whereas the oxygen button is flush with the top of the cover. So to press that, I actually have to get my finger in there. So I really have to press the oxygen if I want oxygen. I can accidentally press the diluent maybe, but the oxygen, if I was to get it trapped between me and the stages or something, it's not going to press. I've got the bottom here, I have inputs, and those inputs allow me to add gas off board. If you wanted an extra plug, maybe a QC6 or something like that, but I can also take off this hose and plug in here and get MAV. Right. Now, it is very easy with this machine to remove the T-pieces. They're just finger tight. You undo the outside locking ring. It's got a few threads on it, right? And there is the inside of one of our T-pieces. So you can see the gas coming from here will have to go in, it'll have to go down because there's a physical block into the counterlung, then it'll have to come up out the counterlung and then back into the machine in this direction. So we've got a physical block inside the T-piece that's made of metal. The fittings are all regulator fittings, and again, just hose to hose connection. Want to fit this back on again, nice and simple. Put it in place, make sure the one O-ring goes in. Once the O-ring's in, and just tighten that up. Okay, so of course I was fitting these to the machine, and I need to make sure that I fit them the right way around. Fit the counterlung set up. You would of course fit your wing first, then your counterlung, and then your back plate to sandwich everything together. Stuff over there. I'm going to put my counterlung set on the screw. It's nice on this rebreather because the top bolt is longer than the bottom bolt. Because the top bolt has to go through the webbing of the harness as well, they took the time to actually put a slightly longer bolt in. That means that you can fasten it on with less effort. It makes it a lot easier having that slightly longer bolt at the top there. There's my top one, and there's my bottom one. Of course, there's 3 positions to the counterlung, as you can see. So having the counterlung in the correct position as close to your lungs as possible will reduce what we call static lung load, and that's the effect of the lung being out of position that affects the amount of breathing effort that's required. So you need to make sure that the counterlung's in the right place for your body. That's really important. We're then going to turn these over so you can see. So I'll bend that one like that. I'll bend that one like that. Okay, of course, great. So you can see now we've got everything in place. Check my checklist. Long screw on the top, small screw on the bottom. Install the BC, we're going to say that's done. Install the put gas supply hoses through the BC if necessary. Install the T-pieces facing the BC, done. And install the backplate and harness, technically done. Attached to the counterlungs is our next step. So underneath the T-piece, you can see we have a Velcro attachment. And that Velcro attachment is one piece of Velcro, and then a locking piece of Velcro, and then our double piece of Velcro. So it's actually held in with 2 pieces of Velcro in the middle. So it traps itself really well. And you're going to need to put that over the harness. If you don't do that, what will happen is when you're diving the rebreather, these lungs are full of air, they'll rise up higher. Okay, you need them down on top of your lungs. Moving them higher puts them at lower pressure than you, and that then makes it harder to inhale. Okay, so we don't want that. We want to keep it streamlined with our body as much as possible. So you need to make sure that those counterlungs are then strapped down to the harness. Got a checklist point for it, and we've done that. Okay, the next step, install T-piece breathing hoses to the head. Clean and lubricate the O-ring grooves and install finger tight. Simple stuff. Take a look at the fitting. It's got an O-ring on there. If I need to remove the O-ring, use the back of my little wooden sharpened paintbrush, just lift that O-ring out. We won't on this machine because it's spanking new, but you could also pinch and push. I don't know if you guys have seen that as a method of removing O-rings before. If you don't want to use any tools on your O-rings, pinch from both sides You'll see the O-ring will lift up and push forward with one thumb, and it'll pop off nice and simple. Make sure that O-ring's got not any grease in the groove. If necessary, cleaner. Make sure that that's nice and clean. Get a little bit of grease on your fingers, inspect it, and pop it into place. Is there any way the gas can bypass the metal separator in the hoses? Yeah, and it's not the end of the world. So if the gas is bypassing, it doesn't really matter. The gas is going that way anyway. The actual metal plate is designed to be a water trap, so the water doesn't enter the scrubber and eventually into the cells. So it's just a water trap more than it's a gas trap. Gas will always find the easiest way, and gas likely will just dip down and go up over the top. So it's not a gas flow director, it's a water flow director more than anything else. Of course, because it's metal, it'll be cold, and that means the hot warm air will condensate on it and drop off as well. So it's actually even better. Is the Hollis BOV better than the Golem BOV? What are the pros and cons of each? So I can't comment on the Golem BOV. I'm not a massive fan of it myself, but I can comment on the Hollis BOV. What I can tell you is the Hollis BOV is one of the lowest worker breathings of any BOV. It was actually considered by a couple of other manufacturers to use on their designs, but I can't go into detail on that. And it's a fantastic BOV. Problem being, fitting the BOV to this rebreather out of stock is it's not CE. So you need to buy it with a DSV. And if you choose to put on the BOV later, that's your call. The BOV itself, however, is CE. So the BOV CE, the rebreather CE, they're just not technically CE together. So if you want to install it as an end user, we can sell it to you and you can fit it no drama at all. Right, I'm going to check that. I've inspected the hose, and then it makes sense that it fits on the left side. So I'm just going to push that into place. Again, once it's in place, I just tighten slowly with my fingers the locking screw. Of course, remembering that it's opposite hand this time. Of course, with all these things, just be careful when you're screwing plastic to plastic that you don't want any cross-threading. Not a problem to buy a new one and change it, but you don't want that to be the morning of your boat dive. So I'll just pop that into place. Takes a couple of turns, and again, don't go too tight. It's only to hold the O-ring in place. The O-ring does its job. And then we've got the XL side. Again, make sure a little bit here, there, get rid of that. Make sure it's nice and clean, inspected, and then we can pop it into place. Now, like I said, this one I find a little bit more difficult because of this solenoid feed hose being right in the way. So what I have to generally do is kind of fit it in place a bit, push it till it's square, and then with my other hand on the back, tighten it up. So now that's in place, I can get two hands on both sides. It'll go a little bit tight when you get to the O-ring, just keep going, then it'll go easy once the O-ring's in place until it bottoms out. Nice and simple. So as we go through, now install the hoses finger tight and do not make sure the nut is the right way around. Okay, so don't over tight, go cross thread and make sure the right way around. So they are now fitted in place. Then we're going to go ahead and it says attach the gas supply lines to the diluent and oxygen addition blocks. So that's simple. We take our BCD feed or LPI feed, we're going to pass it inside this loop hose here, down. We've taken the liberty of fitting some little bits of inner tube. You could make some nice neoprene covers. I think Hollis Rebreathers was planning to make some nice neoprene covers, or you can get whatever you want. We just fit, of course, we like to make things nice and streamlined, so a bit of inner tube on there. Same thing, another one a bit further down. Bit of inner tube on there. And then, of course, it's a standard connector, so just pull, pinch, push fit. So there's our manual side for our oxygen. Same thing on the diluent side. Find the inflator, pop it behind the counterlung. Goes underneath the feed for the ADV. Similar thing. We keep it nice and neat with a little bit of inner tube. I thought we were going to be joined this morning by Nick Hollis. Nick Hollis, are you online, buddy? Nick Hollis is our main man, quite a cool guy. I believe he's gone skiing in the mountains, so he'll be joining us at like 4 AM or whatever time where he is in the US. And that's our manual feed for our diluent side. So we've got a manual feed. You can see that they're nice and neat. When you're on your shoulders, they're going to fall directly in front of your chest, somewhere around a little bit lower than your D-rings. Personally, I'd shorten those if it was me. I'm a little bit squat, so having long ones, especially when I lean forward, I don't want those dangling in front of me. Again, personalization, you can do that really easily. You can also put an inner tube around your harness so you feed it through there, again, to keep it all nice and neat. Remember, most important rule of scuba diving is to always look cool, so we need to make sure we consider that as part of it. Now, O2 supply hose to the manual addition block. The next thing is attach the diluent supply hose to the manual addition block. Attach the ADV supply hose. So our ADV supply hose is our regulator fitting. It's this one here. I'm going to pass it up underneath the loop hose again. And then, got an O-ring inside. Have a check, make sure the O-ring's clean. And that is going to screw on using the fitting directly here. That fits onto the top of our ADV. As we descend, the loop volume will compress. As the loop volume compresses, we have a diaphragm on the top here. That diaphragm will compress, it'll touch the ADV lever, and the lever will let diluent gas into the rebreather, bringing our loop volume back up to a significant amount, to the right amount that we can breathe from. So again, nice and simple. Those of you that have seen our other videos will notice that this ADV doesn't have a flow stop or a shut off at the first stage. So in the event that the ADV free flowed automatically, you would need to shut down the valve. So you'd reach back and you'd turn the valve off. Turning the valve off will mean, of course, you lose ADV. It'll mean that you use manual diluent addition, and it will mean that you lose the ability to run the wing. Okay, so all diluent components would be off. I'm going to make sure then that I pop my hoses, my SPGs down. You can then put that on the other side to make the best hose routing. So I can find my hoses. They're going to go over the shoulders as well. One that side there, and then same on our O2 side. Again, try as best as possible, gents, ladies and gentlemen, to keep your machines as neat as possible. So there we go, manual addition diluent, manual addition oxygen. Okay. It now asks me to attach the BCD inflator, which is this one here. We're not going to connect that today because we are pretending that we've connected our BCD. Okay. The next one is assemble the DSV. Let me take a look and show you guys the DSV for the Hollis. So it's a really small, quite simple DSV. We have our two hose fittings on the end. Of course, one end is completely open because that mushroom valve is stored here in the loop hose. On the other side though, we do have our other flapper valve or mushroom valve, okay, and that's on our XL side, and that one is there. It comes in a carrier, we can pull the carrier out, we can change that quite easily. You'll notice that we've got a plastic body with a steel insert, and that there really is a hell of a machine component. It's got a bit of weight to it. Again, it acts as a loop weight to keep the loop down when you're breathing from it so it doesn't pull against your mouth. We have two positions. That position, of course, like all rebreathers, is flowing through the DSV, and when we close it, we go in that direction there, and that closes it. When you breathe out through the closed position, gas will just come out through this little port on the bottom. So CCR mode, not CCR mode, okay? Nice solid button there. Again, even with dry gloves, you can operate that. It is a bit stiff. I'm having to use two hands, but I'm told the more you use it, the easier it gets. So yeah, it's actually getting a bit easier as we go. So I'm going to start to assemble this and make sure that I put it the right way around. So what I need to do then is I'm going to assemble one side. Just tick to say we've opened and closed the mouthpiece and checked it. Chest and mushroom valve seals for flow direction. We have. Install onto the hose. Pop that here. That's screw tight. Again, orientation of this is quite important. If you have it slightly out of cock, what it'll do is it'll pull against your mouth. So try to align it as best you can. You just screw until it stops there. Again, you've got adjustment in there. You can turn the hose because it's on the O-ring seal, so that's nice and neat. Same one here with an O-ring in here. We check that side and we can fit that side again. See, it's loose. Keep tightening. Everything will become tighter. It'll fall into place. Try as much as possible to get into good habits. When it's not in your mouth, you make sure the loop is then closed so nothing can enter the loop. It now asks me to install the head-up display holder and attach the cable to the breathing hose. This is our head-up display. A head-up display is exactly the same display that you've seen on the JJ. Okay, so this is the shear water hood. Okay, it has the same thing, the dive can connector on the end, but the nice thing about it is it's got this over the top screw connector. So that just stops the two parts being able to be pulled apart. It's not a watertight connector or anything like that. It just stops the two parts being able to pull apart. And the hood holder is a device with a few little elbows in it that allows it to then move around. So what we're going to do, turn it to the side slightly. I'm going to make sure we put the hose inside this little bump bar on the top so nothing can get damaged. And then I can connect that with our dive can connector, which is only a one-way round, can't go any other way. Fit in. Like so. And we're connecting blue to blue, so we know we're on the backup side or the backup monitoring side. You then take the two sections, you screw them together, and that will stop them being able to be pulled apart. So pop that through there. We then got our hood cable. Our hood is going to end up eventually at the handset, so I'm going to just take off the hood from the holder, fit the holder to the DSV, pop it in place, and then we can make sure it's the right kind of orientation. Then that's held in place by this O-ring, which you put over the top there, keeps it all in place. Then we can then just twist it around, kind of get the angle that we want. I'm going to bring the hood, I'm going to make it nice and neat. I'm going to wrap it over a couple of times, one time, maybe two times, so I'm comfortable. And then make sure that I have my LEDs, my rows of LEDs. I've got 3 rows of 4 LEDs and 1 LED on the end. Make sure that they are facing towards the diver. So there you go. If you want it in the middle, towards the middle of your boat, middle of your site, you can see it like that, or you can adjust it right over to this side and have it over to the right-hand side of your site. You can also put it on the left if you wanted to. So that's our hood fitted. Right, the next step is to clean the head to bucket sealing O-ring. So now we've done and assembled the front of the rebreather, it's time to work with the back of the rebreather. So I'm going to spin it around so you guys can see the back. At the back, we have our sealing O-rings, and these sealing O-rings seal the bucket to the machine. So these are red. Okay, these O-rings need to be inspected. Inspect those, make sure they're clean. If necessary, of course, pinch push. They can pop off. Always with these critical O-rings, they're red. If you're going to take a critical O-ring out, do not put it down. Keep it in your hands until it's back where it should be. That'll stop that you'll be able to put it down, go make a cup of tea, put the scrubber on and forget about it. So always with these O-rings that are important, take them off, inspect them, clean them, and put them directly back into place. So I'm going to fit that one back into place immediately. Great. Best bet now is to lean the machine slightly further forward. Lean forward, and hopefully you guys can see what's going off. Okay, great. So we've got our 2 O-rings inspected on the top there. Remove O-rings as per instructions and clean if needed. Clean and replace. Great. Clean the red CO2 seal and secure into place. So again, our CO2 seal is this one here. We spoke about it earlier, but I'm going to make sure, number 1, the groove in which it sits is clean. I'm going to make sure if I need to, I take some cleaning and I'm just make sure that the CO2 seal is clean. No hairs on it, no damage in it. And then I'm going to pop the CO2 seal again back in place. Super important again, because it's red, make sure you don't put this thing down. Make sure it always goes back in the rebreather, it's critical. It's clean, and that's fitted now into place and it'll stay there. And it says, make sure the red CO2 seal is firmly seated in the groove, triple check. So we've done 1 check. We'll check again. That's firmly seated, it's not lubricated, it doesn't need to be lubricated. And then again, let's do a 3rd check to make sure that that's in place. Why not? And it takes a second. The next one is to check the bucket. This is our scrubber bucket. You can see in the bottom of there, you've got a sponge. That sponge will collect any moisture. It'll become a bit thicker than that when the first time it's used, but this is a spanking new machine. That fits over the top of this spring. So this is spring loaded to make sure that that scrubber pushes against that sealing face. Okay, so I'm going to check the bucket. Take a look, inspect the top sealing face, make sure there's no nicks, grooves, damages or breaks that are going to damage those O-rings. Check the basket secure. Check the firmness of the absorbent bed. So yeah, everything's good. Check the scrubber itself. Make sure everything's secure. Make sure the top sealing face is in good condition. And we're good. Right, now I'm going to make sure that the spring is functional. Press down on there. Make sure that inside our bucket it's moving. Make sure the moisture pad is inside. And make sure this pad is not interfering with the movement of this spring. Okay, if that sponge was to get trapped in that spring and it wasn't able to compress properly or at least expand properly, it might stop this rubber being pushed against the top there. It's very unlikely, but again, make sure you do your checks. Place the CO2 basket inside the bucket. Confirm center tube opening up. Okay, so we see our CO2 seal, red instructions on the top. Record usage time if necessary. Just push down, make sure that goes into place. And now I'm going to mount this bucket to the machine itself. To do that, what I do is I use these latches. There's a latch here at the very back. There's a latch on the right, and there's a latch on the left. I'm going to just tip the machine forward, push it into place, and then press on the top of the head and press on the base of the canister, and that will go up nice and neatly into place. When I'm relatively happy, I can just lift those locks up, put one on there, lift this lock up, latch up, sorry, not a lock, lift this latch up, that one goes in place, and I can lift this latch up, and that one goes in place. When I'm ready, I'm going to do the two side ones first, just because I'm that kind of guy and I like to make sure it goes up nice and neat, so I do those at the same time, and then I'm going to do the back one and make sure that goes up. So stand it up, you guys will see that the latch fits onto a metal rim around the top here, so it hooks over the top of one here, and one here. So now I've latched the scrubber into place, it's pulled it up. I can very easily see that these two red O-rings are in place. Okay, because I've got a clear bucket, I can see easily two O-rings in place, no damage, no debris inside, and it's fitted all the way around. So that's cool, and my scrubber is in place. Done. Mount the cylinders to the H plate and put the first stages on. How is this attached to the metal bucket? It's bolted through from the inside. Sorry, Sam, what do you say there? What's stopping the scrubber from falling off the centre when it's pushed into the head? It's actually the post on the bottom fits up inside, so that even if you do, as soon as you tighten it up again, it'll pull itself back into square again. So that on the base, that spring will actuate and move slightly. So when you put it up, it'll all go back into place. I'm going to do the diluent first because that's the closest to me. Take it. Lift it through here, like so. This one through here, like so. I always just get the right height first by tightening the top one, just to kind of hold it in place. Tighten the bottom one a little bit while I figure out what I'm going to do with my first stage. Take the first stage cover off. Lift up the hoses, and then I can tighten the first stage into place. Myself a little bit more adjustment room. One side, and then tighten the other side. One, two. First stage, finish tightening that off. We're happy with the first stage. Same thing now on the O2. Two side goes in. Put it somewhere about right, do the top one up. Spend a bit of time just to get the bottom one in place. Personally, if it wasn't my unit, I'd have took these first stage covers off, put them in my box. Tighten that. Then when we're happy again, just tighten these Velcro cam bands. Now the Velcro cam bands, I'm surprised actually, even if I put a bit of weight on there, they hold it really, really steady, which is surprising because I thought they'd move. So oxygen side fitted, diluent side fitted. So James, are there O-rings around bolts then? How is the water tightness achieved? Yeah, through here. So basically it's got a groove and it sits on top of the groove there. It's then kind of put on the top and it looks like it fits against the top there, so it doesn't work. So there's no bolts going actually through. It's kind of against this lip and then glued into place. Right. So that now is our assembly checklist complete. Okay. So the machine is fully assembled. What I'm going to show you guys, just because I disassembled it, I wouldn't normally take this piece off. We have, of course, our Shearwater Petrol 2 controller. If we undo the Shearwater Petrol 2 controller, this is going to fit on this side. Again, just push it through with our dive can connector. We pop that into place like so. Screw up the two retaining pieces. Make sure that that dive can connector can't come apart. I like to pop that for the minute just there on top of the cylinder. Okay, so you can see the build-up process was quite simple, and you can see that now the machine is fully assembled. It's not that much bigger or smaller than any of the other rebreathers we've built. It's about the same height, but what we have got is we've got a lot less volume. So all of this under here is all empty, stuff like that. So I imagine you're going to need a little bit less weight than some of the other rebreathers compared to its displacement and its volume. What do I do with my pen? Right. The next step that we're going to do and show you guys is the operational checklist. So this is to make sure that everything we've done so far is working. I'm going to test the rebreather's capability now. So it's asking us, is this an inter-dive one? And it's not. This is the build-up. And is the scrubber new or used? I'm going to say the scrubber is new. Is the assembly checklist complete? That's our first one. So did you assemble your rebreather? Yeah. Analysed and labelled gas cylinders? Yes, we did. The first thing it's asking me to do is turn on the wrist display and check the millivolt readings of the cells. The acceptable range is 8.5 millivolts to 14 millivolts. Replace if needed. So, take my Shearwater handset. Press the two buttons. It'll turn on. You get a warning screen here. It says, I've confirmed I've been trained to dive the Prism 2 and will not exceed my training. If you don't do that in a minute, it turns itself off. So I'm just going to accept that. Okay. Then the Shearwater handset will turn up. You can see this machine's been out of the water about as long as everybody else has been in lockdown. And we press the right button once, twice, 3, 4 times, and we get our cell millivolt readings. So we have 12, 11.9, and 11.7. For posterity, I like to write those down. 12, 11.9, 11.7. So they are within the acceptable range. The next step is to move the machine to surface set point. To do that, what I'm going to do, I'm going to scroll through the menu using the left button, and eventually I'll see set point to 0.19, and I'm going to activate that, and it'll tell me that the set point is 0.19. That's our surface set point. With the set point being 0.19, it means that the machine will not inject any gas even if it's exposed to air. With air being 21 and 0.19 being less, the only way that this machine will inject gas is if the loop volume, so the loop PO2 drops below 0.19. Unless I'm breathing from it with everything turned off, that won't happen. So we're good to go. Not with everything turned off. If I breathe with it turned on, same thing. Now we've done that, I can tick that. The next step is to turn on the hood and check the battery status. To do that, very simple. Bring my hood around. I'm going to press the side button. Let me remove it so you guys can see. And with this Shearwater hood, you basically turn it on, and if it doesn't give you the low battery warning, you assume it's good. You're going to see it pull through the lights. Set of red, set of green, set of yellow, set of red, and then an upward pointing position. And that shows it's in the right direction, pointed upwards. Hopefully you guys can all see that. And it's flashing now, and we get every flash is 0.1 below 1. So if we look in, we get, ready, 0.9876543, 2, Okay, so point 2, 21. That's about what we expected inside the rebreather. Put the hood back into place. We haven't got the low battery signal, so that means the hood is in good condition. At least enough battery to go diving. Hollis make a really nice reference guide for the hood for those people who want it. You can print this off on a little card, put a hole in it, punch it, keep it in your pocket. There's 2 sides to this. You have this side which tells you what the commands do, how to get into it, and this one tells you what the PO2 means. And you can see quickly that the low battery display is 3 yellows on the bottom there. I think hopefully you can see that. 3 yellows on the bottom there. After 30 seconds, that means the low battery and battery should be changed. So quite a nice thing. So, Pete, are the cylinders secure like that? Well, let's give it a bit of a test. No, I'd say they're pretty secure. I pick the unit up by them. Give the unit a shake. Yeah, see, it's pretty secure. I wouldn't imagine during normal diving that they should come loose. Rolling off the back of the boat, they seem secure enough for that too. They can't drop any lower because they'll hit the frame. This isn't my unit, so I don't mind doing that, to be fair. But everything seems pretty tough. They are Velcro, so I guess from time to time, you want to make sure that Velcro is in good condition, but it's super cheap to change a Velcro strap, so actually looks pretty strong. Turn on the hood and check the battery status. Fantastic. The next one is the oxygen system leak test. So I'm going to turn it around to face you. If the Velcro gets wet, will the slip between dives? I guess like your BCD, if you wanted to put belts and braces, you could, of course, make sure that you wet the Velcro before you put it together. But I doubt it. When the Poseidon came out, we had Velcro on the Poseidon for a long time. That was never an issue. We use Velcro on the AP as well. Not much of an issue. So generally, I think it's probably going to be all right. They've got rubber slip pads on there as well. So when you tighten it, that rubber will compress a bit. So even when it does get wet, when it expands, that rubber will probably take it up. Right. Now, oxygen system leak check. Hold for 30 seconds minimum. So slowly open the oxygen valve and pressurize the hoses and then close the valve. So what we're going to do here, we're going to make sure we turn our O2 on, and we're going to make sure we turn it on really slowly. Remember, the new advice is kind of 2 minutes to turn your oxygen on, as best as you can achieve actually with the valves we've got. There are new valves coming in the future that are a bit slower, but let's just turn that on nice and slowly. Does the blinky eye thing work the same as the JJ? Yeah, I'm glad I trained you on the JJ, Dave. Yeah, the blinky eye funny hoodie thing, it works exactly the same. So just turn it on nice and slowly. Really slowly. Okay, we're up to 10 bar now. 20 bar. 25 bar. That's nice and slowly. We don't want any oxygen rushing through the system causing us any problems. Turn the O2 on. Let it pressurize up. You can see we're trying to go as slow as we possibly can. Pressure's building up slowly. Okay, oxygen's now fully on. I'm going to open the valve, make sure that the whole system's pressurized, and now close the valve. Now what I'm looking for is any loss of pressure. So a minimum of 1 minute, I'm going to wait. If when I turn the O2 back on, the needle jumps back up, yeah, that means that I've lost some oxygen in the oxygen side. So we're going to wait for a minute. We're looking. Interesting thing about this rebreather, the way the checklist is done, we actually have the solenoid powered. Well, not powered, but turned on. So all the electronics are turned on. Even though it's in surface set point mode, it shouldn't fire. And that means that if the solenoid was leaking slightly because of some kind of voltage leak, you would detect it at this point because you get pressure drop in the O2 side. So we wait for a minute. Then when we turn it back on, keep an eye on the gauge, and I want to make sure the gauge doesn't jump up. There we go, and the gauge stays exactly where it was. So I'm going to open my oxygen. Fantastic. The next thing is to negative pressure test. Hold for 1 minute. So open the DSV, inhale in CC mode, exhaling through the nose until the counterlungs are fully collapsed, and then close the DSV. So this is the same negative test that we do on a lot of the rebreathers. I'm going to lift the loop up. I'm going to inhale through my mouth, exhale through my nose, collapsing the loop up, making sure that we get a vacuum inside the rebreather. Once I've got a vacuum, I'll close it. Would you believe it? I managed to make the solenoid fire by creating too much low pressure. So I'm just gonna turn it off for a minute. I'm actually pretty good at sucking a negative, I'm told. I can suck a golf ball down 20 meters of hose pipe. So I'll create back negative pressure in there and it drops the PO2. Okay, fantastic. So what you can see is you can see that hoses have all collapsed up. If those hoses were to start sagging and come down, then you'll notice that the loop itself is leaking. So yeah, Brian, you can join us later. This will be posted on YouTube. It'll also be staying on our Facebook afterwards, so you're more than welcome to pop in and watch it later on. So we've got it fully set up now. We're going to wait for at least a minute. Once we've waited for at least a minute, we're going to watch for signs of leaks. Looks like it's all pretty good. You can always hear these things as well from time to time. And we're happy. So that's good. Our negative pressure one passes. Now, what we're going to do is we're going to do the positive pressure test. Now, I mentioned earlier that this machine is a different calibration procedure. The calibration procedure starts now. We start flooding the machine with oxygen from this very point. So to do my positive, I'm going to use the oxygen manual add and manually add oxygen to the rebreather. And you'll notice that my loop, which was a positive, sorry, on a negative test, will start to become positive. See that sink in? Now those that will notice, it's a very slow flow of gas. Really, really slow flow of gas. If I compare that to the diluent side, if I put the O2 into the diluent side so you guys can see the flow, look at the flow on the diluent side. You ready? You see how that comes up that much faster? More flow of gas on the diluent side. So, put into the oxygen side. And then we're going to add gas. I'm going to blow the loop up now to positive. So it takes a moment. Just keep my finger on that. What I'm trying to do is I'm trying to blow the loop up to positive pressure until the overpressurization valve, which is on the counterlung down here, until this, move that out of the way, until this overpressurization valve pops. So check it's working. Keep filling the machine with loop with oxygen. You'll see the counterlungs raise right up. And then listen for the OPV. There's my OPV leaking. So that's fantastic. So I'm going to bring the handset around so you guys can see it. Okay, so hold for 1 minute minimum. Close the OPV, fully filled with oxygen. We're done. Okay, and then wait. So now we're waiting. We want to feel this tension that's inside these counterlungs. Okay, this wants to stay the same. If the loop was to start to sag, then we've got gas leaking from the rebreather. So we're going to leave it for a minimum of 1 minute, fully inflated, looking for leaks. Okay, allow it to sit for 1 minute. When you're happy, open DSV and evacuate the loop contents. As we do that, you see it will flood out. Close it again. And what you can see, let me just connect this back up so I don't forget. What you can see on the handset is that the PO2 has risen inside the rebreather. We're already at 90% based on our last calibration. So put that down there. And then it's going to tell us to flush the loop 2 more times, so which is the same process. So what we're going to do is we've evacuated the loop. I'm going to fill again with oxygen. All the way up. And there's a couple of ways you can evacuate the loop. We can use the DSV or we can use the OPV. We want to make sure we get all the machine covered in pure oxygen. So we want those cells with pure oxygen. So that's fully inflated. Once it's fully inflated, I can use the OPV and squeeze the counterlungs if I want. Get those right down. That's one. And then again, one more flush with pure oxygen. Bring it right up again. Again, if you're doing this lying down, you wouldn't need to put so much oxygen in because the counterlungs wouldn't expand so much, but we're going to be doing it stand up so you guys can see what's going off. We haven't even used 10 bar yet, so it's not the end of the world. And again, we'll use the DSV this time, let the counterlungs evacuate, close that, and then the last one, flush it with oxygen all the way up. And you can see here, look, we're coming right up with oxygen inside the rebreather. So we fill it up, and we're happy the machine's full up. Okay, we're then going to open the DSV, allow it to come to ambient pressure. So you guys know that if I didn't allow the loop to come to ambient pressure, I would have increased ambient pressure and high oxygen, so I would get a difference reading with the PO2. So that's now ambient pressure, there's no pressure inside those counterlungs. I can then go through to my calibrate screen. I tell it this is 56, 55 millivolts is pure oxygen, and I want to calibrate. Press calibrate and it'll give me my calibration report. So calibrate the wrist display, check millivolt readings between 40 and 66 millivolts. So I have 56, 56 and 54. So they are within tolerance. Next step is to calibrate the hood. To calibrate the hood, what I'm going to do is I'm going to press the end button. That's menu 1. Press it again. That's menu 2, that's calibrate, and now I'm going to long press and hold. And this will calibrate to 1. And in a minute you'll see yellow and green, and that's our PO2 of 1. So PO2 of 1 over here. PO2, if I confirm this one, of 95 across the board, which just dropped slightly. And we are now calibrated. Check the solenoid and wrist display battery. Check the batteries. What I'm going to do, use the handset. I'm going to go through using the right hand button, our information screens, tissue, and then we're going to wait. You see here we've got a question mark on our battery voltage for our internal batteries. That's because the solenoid isn't fired. We can see we've got 1.43 in the battery in here. To make the solenoid fire, I'm going to switch to low set point and then switch to high set point. Here's one fire of the solenoid. Then you're going to hear another fire of the solenoid. As you can see, the PO2 is increasing in the rebreather because the pressure is increasing in the rebreather. 3 fires the solenoid, and then I'm going to turn it back to low set point, turn it back to surface set point. I can now go through my screens to my tissue screen. Next press 8.4 volts on my internal 2.9 volts and 1.43 on my 1.5 volt inside here. So we can check our battery voltage. Just going to let that oxygen out the loop. Fantastic. Check it fires, check the batteries are inside acceptable range. The next step is to install the cover. So I'm going to turn the rebreather around. This is our cover. It's a lightweight plastic cover, keeps the weight down. It's quite well protective. It protects the electronics module and the battery compartment and the hoses. What you're going to do is fit it so that these two sides fit over there. And then on the top, just line everything up best I can. And then align the top part, press it in slightly. Where are we on this side? There we go. It'll clip securely into place. That then is pretty well on there. It just makes the machine a little bit more streamlined, a little bit more protected from wrecks or caves. We now need to check our diluent side. So I'm going to go to our diluent side of the rebreather. I'm just going to pop the handset on the top for you guys. We're going to check our diluent side. First thing we're going to do is a high pressure test again. So take my SPG, make sure it's covered, and turn on my dill. I can turn on a bit faster, being just air. See them at 200 bar, wait for a second, and then of course turn it off. I'm going to wait for 1 minute, looking to make sure there's any leaks now on the diluent side of the rebreather. After 1 minute, take your SPG, turn it back on. Any jump in the needle will mean that there's a problem on the diluent side. So look a little bit neater, look. There we go. Watch diluent pressure gauge and then open the cylinder, which we've done. check the ADV and BCD. So to check the ADV, I can't press it like I can on some of the other rebreathers. I'm going to actually need to use the loop itself. So I'm going to put the loop in. I'm going to vent through my mouth, in through my mouth and out through my nose. So as I inhaled there, you heard the ADV fire. So the ADV is firing and it's working. Check the ADV. Check the BCD, which I would do. I'd fully inflate the BCD, make sure the overpressurization valve works on it, and check then all the dumps. I would then do a pre-breathe on the rebreather, which means to breathe the rebreather 3 to 5 minutes, making sure that I'm checking the functioning as a rebreather and that all the systems work. We get PO2 drop and it's monitoring on both systems, and then PO2 increase again as it's adding the oxygen, keeping an eye out for signs of CO2 if possible as well. Pre-breathe we'll say is done. If diving immediately, continue with the pre-dive check. So there's a small pre-dive checklist to do if you're just about to jump in the water. You'll need to do the training to see that one. You're going to make sure you've got your weights on, your hood's in place, cylinders are open, make sure your set point and gases are set up, put it on, do the pre-jump, which is to get them ready to get in the water. So that is the Hollis P2 assembly and checklist complete. Okay, you can see it's quite a simple rebreather in its design, which is nice, keep it simple philosophy. It's quite a small rebreather in its design, and even now, fully kitted, ready to go diving, we're at 25 kgs. Okay, so we're not talking about a lot of weight. Steel cylinders on it. You could go to aluminium cylinders if you wanted. You could go to a slightly lighter backplate if you wanted. But in general, the machine's great for that kind of work. Manufacturer supported, of course. All parts available for the UK. Plus, it's got the shear water electronics. So really, really kind of forefront of rebreather technology. It's now available through all of your Hollis dealers in the UK. If you use the voucher link that was put on there on the chat there, you'll get £500 off a new rebreather. So if you're right on the edge there, thinking about buying one, get stuck in. You've got till the 31st of July to get 500 quid off a brand new rebreather. That's pretty much half your training, right? Well, it's more than half your training. It's 2/3 of your training paid for free by the manufacturer. So I'd really take advantage of that offer if I could. What else we want to talk about with this rebreather? Let's compare it, some of the features. Weight first, we talk about weight quite a lot, but it's about the same weight as the Poseidon, so it's less than the SF, less than the Revo. What's the best / worst bits of this rebreather in your opinion? The best bits of this rebreather, Sam, probably the shear water electronics and the way that it's nice and easy to travel with. That's one of the options I like about it, but still capable of 100 meters CE certified. Radial scrubber is an advanced feature that you buy for most rebreathers, so that's kind of quite nice to see in a entry level when you buy it as an entry level from a main manufacturer. The worst things about the rebreather, I'm not keen on the hose lengths. I think the hose lengths are standard are a bit long. I would personally change those. What else am I not keen about? Personally, the cover. I think the cover is a bit, is a bit plasticky. It'd be nice to have this made again, like I have made with the SF, for instance. I get these aluminium aftermarket covers made. It might be nice to have something steel or aluminium on the top there. I like the simplicity. In-water trim. In-water trim is going to be very similar to any other rebreather that's got valves at the bottom, first aiders at the bottom, counterlungs at the top. So in a wetsuit, you're always going to be trimmed slightly feet down. So you're going to need to put the weight a little bit higher. In a dry suit, it's not going to make any difference. It should trim out really, really well, just like all the other back-mounted counterlungs. What other questions have we got? Okay, Hayden, if you want 10 grand worth of giveaways, all you need to do, deposit your entire bank account to the National Bank of Uganda, and Hayden there will give you 10 grand. Sounds like a winner. What else? Is training available? Yeah, training is available. We have instructors trained throughout the UK. Find your closest Hollis dealer, and they can start training pretty much from the 17th when the dive site's open, I think. You might even be able to get some online webinar training or social distance training inside the centres from the 15th. So you can actually start the academic part right away. The other questions we've got. Seems like it so far. So what we'll continue to do, like always, is we'll put We'll keep looking at the comments, so if you guys have got any more questions you want to add, please do that. If you want to speak to us, no problem at all, send us a PM, send us a message, or hit us up on the comments and we'll come through and we'll let you guys know any details that you want to know about the rebreather, where's your localist dealer, stuff like that. Like the SF2, try and then of course the JJ. The only answer is you must have them all. Yeah, absolutely great. I agree with you completely. If you look, the only rebreather to have is all the rebreathers. You know, he or she who dies with the most toys wins. And these things are super cool. Prism itself, fantastic rebreather. It's one that we've added new to our stable actually. So we're quite keen to get a few more hours on it and get practice. So thank you very much for your time, ladies and gentlemen. Any questions, please add them. Don't forget, go on the Rebreather UK website, get your £500 voucher. Get it now. At least then, if you decide between now and the 31st of July that you want a machine, you're going to get 500 quid off. So thank you for the guys for doing that for us. Click on our Facebook link, on the live links. You'll see all of the other videos, so you can watch them back to back. They're also available on our YouTube channel if you want to watch them back to back. Compare the machines directly one to the other. The other option, and the one we recommend for most people, is when you're ready for a rebreather or you're on the edge of buying a rebreather, get yourself down to the store, come and see these machines, get your hands on them, take them apart yourself, have a touchy-feely one next to the other, and you'll get an idea for which one you probably want to buy. It takes a little bit of time and a little bit of investment to find the right rebreather for you. But what we do say is whichever one you pick, as long as you've done a little bit of advice, that you'll enjoy it anyway. So thank you very much. We'll see you all next week on Saturday, 11 AM. We'll be talking about the Marhez Horizon, which is a semi-closed rebreather, and it's really interesting design actually. So you guys, you just tune in for that. Thank you very much, and we'll see you soon.